installation, and maintenance video. The following program illustrates instructions found in the installation and maintenance manual that accompanied your pump. To get the most from the program, you should familiarize yourself with the format of the manual so that you can quickly locate charts, diagrams, parts lists, and instruction sequences for future reference. Your manual also contains the correct procedures for handling issues such as shipping damage or warranty claims. This program covers instructional sequences under Installation, Maintenance. The Bredel hose pump has solved the problem of difficult-to-pump material for its users around the world. It spends very little of its time out of service for maintenance, and here's why. There are no seals to wear out, to inventory, or to replace. In fact, there are no moving parts in the product zone at all. It can transfer abrasive, caustic, viscous particulate-laden material without worry. The hose is the only part of the pump these materials will contact. The pump will even run dry in complete safety. This remarkably simple pump has only one moving part. Pressing shoes attached to a rotor alternately compress and relax a specially designed resilient hose. Whatever is in the hose is moved along and pressed towards the discharge. The ability of the hose to return to its original shape creates a vacuum, and this draws in more fluid. Lubrication and cooling of the pump hose is taken care of by a specially compounded hose lubricant that partially fills the pump housing. Installation. Before you install the Bredel hose pump, there are 4 things to check: hose type, mounting position, piping arrangement, shimming. The hose in your pump was selected by an experienced Bredel-trained applications engineer for your application. There are 5 types of hose material available. Each one accommodates a different range of fluid characteristics, such as abrasiveness and corrosiveness. The hoses are color-coded. A label around the hose and a mark across the hose end colored white, red, blue, yellow, or green determine which hose type your pump uses. Before replacing the hose in your pump, make sure the color code is correct. You'll find the Bredel hose pump very flexible in installation. It will rotate in either direction. This, of course, determines which is the inlet and discharge port. You can also mount it in any of these 4 positions. If your product tends to settle out when still, this position alternative is not recommended. You can see that solids could accumulate in the hose in this position during dwell or shutdown periods. That could result in a stalled rotor and possible damage to the pump when it is turned on again. There are several things to remember when arranging transfer pipe work to and from the pump. Suction lines should be as short and as direct as possible. The number of bends should be kept to a minimum. Where elbows are needed, use long, slow, sweeping elbows. Plan oversized pipelines to minimize friction losses. Firmly anchor the pump and all attached lines. The shoes that compress the hose during the pumping cycle require shims to ensure that the hose is compressed properly for your application. Under shimming substantially reduces hose life. The shims, each one 0.02 of an inch, are installed at the factory in the right quantity for your application, based on the application information provided. Additional shims are supplied with your pump. It's a good idea to check and verify with the shim chart for your pump shown in the operating manual that the correct number are installed for your specific application parameters. All you need to know is your operating RPM and pressure conditions. For example, with a model SPX40, a pump speed of 60 RPM and a pressure of 109 psi will require 3 shims under each pressing shoe. If the RPM falls between a shim number, always round up to the highest shim number. If the fluid operating temperature will be above 140 degrees Fahrenheit, use 1 less shim than specified by the shim chart. If you need to change the number of shims installed in your pump to match the speed and pressure condition of your application, adding or removing shims is very straightforward. Jog the drive motor until a pressing shoe is visible in the inspection window. Drain 20 to 30% of the hose lubricant until the lubricant level is below the bottom of the inspection window. Make sure all power is turned off and locked out. Remove the inspection window. Loosen the shoe retainer bolt. Remove unnecessary shims or add shims to match the shimming chart and insert them with the slots around the bolt. Tighten the shoe retainer bolt. Turn power back on and jog the drive motor until the other pressing shoe appears in the window. Turn power off and lock out. Repeat the shim adjustment procedure with the opposite pressing shoe. Remember, both pressing shoes must have the same number of shims. Replace the inspection window. Replenish the hose lubricant. Your hose pump may have come with optional sensor switches. When interfaced with the motor, starter, or control, they protect the pump. The high-level liquid control sensor switch monitors the lubricant level in the pump housing. In the event of a hose failure, the fluid level rises and trips the sensor switch, which turns off the motor. This also contains the hose failure within the pump. It installs in the top of the breather tube on the rear of the pump. A low-level lubricant sensor is also available as an option. Your hose pump application may involve low pressures at the inlet, caused, for instance, by friction losses due to high fluid viscosities. These low-pressure conditions can cause reduced flow rate. The Vacuum Assist accessory provides a method that equalizes the pressures inside and outside the pump hose. This enables the hose to open more easily and return to its original shape so it can operate at full flow. This also ensures that nominal hose life is achieved, if not exceeded. There are various systems available, the most common being the external Venturi vacuum pump. This device, that mounts onto the pump support, uses a compressed air supply and the Venturi principle to generate a vacuum within the pump housing. Together with a pressure regulator, the vacuum in the pump housing can be carefully controlled. The Vacuum Assist is an option on models SPX40 through SPX100. A small electrical vacuum pump is also available. Your application may also involve high pump speeds and unavoidably long inlet or discharge lines. If so, your pump came with accessories that help maintain pump efficiency and increase the life of the pump hose. These include an inlet pulse accumulator, IPA, and a discharge pulsation damper, PD. High pump speeds increase pulsations, and these cause pressure spikes at the inlet and discharge. The inlet pulse accumulator and pulsation damper both act as shock absorbers for the pump and the associated pipework. They level out and dampen the sudden spikes of incoming and outgoing pressures, often referred to as acceleration losses. The IPA is mounted directly onto the pump inlet flange and as vertical as possible. The pulsation damper fits directly to the discharge flange. Inside the steel cylinder is a reinforced flexible hose surrounded by a volume of compressed air. Once mounted to the discharge flange and connected to downstream piping, the cylinder is charged to approximately 90% of the minimum pumping pressure. With the pump installed and all accessories in place, it is time for the pre-operation check. Again, is the hose material compatible with the fluid to be pumped? Is the breather tube on the rear of the pump free from obstructions? Do the number of shims match the shimming chart in the operating manual in relation to the pump RPM, pressure conditions, and product temperature? Are all connections tight and securely fastened? Are both inlet and discharge valves open? Has the damper been charged up to 90% of pumping pressure? Does the product temperature exceed 175 degrees Fahrenheit? Will the discharge pressure exceed the maximum allowable of 109 psi for 10 millimeter and 15 millimeter units, and 230 psi for larger models? Maintenance. The principal maintenance procedure for the Bredel hose pump is replacing the hose. Whether the hose change is done on a scheduled basis or following a hose failure, the procedure is the same. Depending on your pump application, the product pumped may be hazardous, and care should be taken to ensure that the correct personnel protection and handling methods are adopted. After closing the inlet and discharge valves, remove the lower drain plug and drain the hose lubricant. In order to remove the hose, you will need to disconnect and remove a section of piping equal to the length of the hose. Remove the inlet port flange assembly first. In this example configuration, it is the lower port. Remove the discharge or upper port flange assembly. The hose will be withdrawn and inserted using the upper port, but either port could be used. Jog the drive motor and allow the hose to exit. Disconnect power. Remove the pump cover. For larger pump models, check the weight of the pump cover in the table in the operating manual. If you will require a power lift, lifting holes are located in the cover on models SPX 50 through SPX 100. The housing can be flushed out without removing the pump cover. but it is important to remove all foreign matter. Opening the housing is the best assurance. Clean and flush the housing cavity thoroughly. Replace the pump cover. Make sure the replacement hose has the correct reorder code for your model. Details are given in the operating manual. Clean and lubricate the replacement hose with a specially compounded hose lubricant. Connect power, turn the motor on, and insert the hose in the discharge port. Guide the hose as the pumping action pulls it through the pump. Stop the pump when the hose appears at the inlet port. Replace the inlet port flange assembly first. Refit and secure the inlet pipework. Jog the drive motor in the direction of the inlet flange and tighten the flange bracket bolts. Position the hose clamp against the flange bracket and tighten. Repeat the procedure for the discharge port flange assembly, not forgetting to jog the drive motor in the direction of the discharge flange, as this also produces the correct hose tension within the pump housing. Tighten all clamps and bolts to the correct torque setting as given in the operating manual. Fill the pump housing with the required amount of hose lubricant through the breather tube mounted on the rear. To pour lubricant into the breather tube, remove the breather cap or the sensor switch if installed. Remove the top plug to vent the pump housing. The lubricant level must exceed the minimum level indicated on the inspection window. Replace the top plug. It's important not to run the pump until you have reopened the inlet and discharge valves. At this time, you can run the pump and check it for general mechanical function. In summary, the Bredel hose pump is unique in the world of pumps. It is easy to install and simple to operate. The pump can be serviced in place. There are no moving parts in the product zone. The hose replacement in the example shown takes generally less than 30 minutes with no special tools and no critical adjustment. Contamination-free, the pumped fluid is contained entirely within the hose, separated from the pump. No other type of positive displacement pump offers this unique separation of the pump and fluid. Glandless construction, with no seals, valves, diaphragms, glands, immersed rotors, stators, or pistons to leak, clog, corrode, and replace. Hose pumps are hygienic and easy to clean. Spare part inventory investment and management are dramatically reduced. Safe dry running. The hose pump does not need fluid in the hose to cool or lubricate it, and can suck air intermittently or continuously without damage. Self-priming. High suction lift for maximum flexibility of installation. Fluid temperatures up to 175 degrees Fahrenheit. Pressures up to 230 psi. Limited to 109 psi for 10 millimeter and 15 millimeter models. Output is directly proportional to pump speed and independent of pressure conditions or fluid viscosity, giving superb metering capabilities. There is no slip, since, unlike other positive displacement pumps, the Bredel hose pump offers slip-free true positive displacement. Reversibility means fluid can be pumped back to source, saving cost and making draining down easy. As the hose is fully closed, backflow and siphoning are eliminated, with no valves needed. Abrasive, aggressive, high viscosity, high density products such as slurries, corrosive acids, gaseous liquids, and shear sensitive products can all be pumped with confidence. Should you need further information on the installation, operation, or maintenance of your SPX hose pump, please contact your Bredel distributor.